Okay, I want to look at a little more tricky example of a totally elastic collision. And we talked about how these aren't all that common, but they do serve as a good model for a lot of different types of collisions because they're close to elastic. So this example is on page 203 of the text, and it's number 21. It says, a ball of mass 0.44 kilograms moving east in the positive x direction with a speed of 3.7 meters per second collides head-on with a 0.22 kilogram ball at rest. If the collision is perfectly elastic, what will be the speed and direction of each ball after the collision? Okay, so first of all, we have two objects. We have mass 1 of 0.44 kilograms moving in the positive x direction at a speed of 3.7 meters per second, and it collides with a 0.22 kilogram ball that's not moving at all. Zero. And then afterwards, they hit and they bounce off because it's elastic. They don't stick together. And they want to know how fast is each ball moving after the collision. So again, I'm going to use that prime notation, the V1 prime and the V2 prime notation, to make sure we know the difference between before and after. Okay, so here's the deal. With the collision, any collision, P before is equal to P after. So I have two separate objects before the collision, so I can write that M1V1 plus M2V2 equals M1V1 prime plus M2V2 prime, because I have two separate objects before the collision, so the momentum of each, and then two separate objects after the collision, so the momentum of each. The problem here is this isn't enough to solve the problem, because look, I have V1 prime and V2 prime both unknown, and only one equation to solve it. Okay, so I need another equation. Well, luckily, since this collision is elastic, then I know a second equation, and it's a kinetic energy equation, and that is V1 minus V2 equals V2 prime minus V1 prime. So I'm going to work with that to start. Okay, what I'm going to do is I'm actually going to plug in the numbers to this equation. Okay, so I have V1, which is 3.7 meters per second. V2 is 0, and then I'm going to add V1 prime to both sides. Okay, I don't have a number for it, but plus 0 plus V1 prime equals V2 prime. Okay, so I could write this as 3.7 plus V1 prime equals V2 prime. What I'm then going to do with that is I'm going to plug it in to my momentum equation that I had up there, and I'm going to solve it out for one of the primes. So I'm going to have M1V1 plus M2V2 equals M1V1 prime plus M2. Instead of writing that V2 prime, I'm going to write 3.7 plus V1 prime. So I made a substitution there. Okay. Now I'm just going to distribute the M2 across those parentheses. So I'm just going to rewrite the right side of the equation here. It's going to be M1V1 prime plus 3.7 M2 plus M2V1 prime. Okay, the left side's still the same. All right, so my next step, what I'm going to do is get all the primes on one side of the equation and all the non-prime things on the other side. So I'm going to have M1V1 plus M2V2 and then minus 3.7 M2 equals M1V1 prime plus M2V1 prime. Okay, next step, I'm going to leave the left side alone. I'm going to factor a V1 prime on the right side. So that's the same thing as V1 prime times M1 plus M2. Okay, now if I take that and divide both sides by the quantity M1 plus M2, I now have V1 prime by itself. So I'm going to have M1 V1 plus M2 V2 minus 3.7 M2 divided by the quantity m1 plus m2 equals v1 prime. So now I have it, and these are all numbers that I can calculate, okay? Look at my calculator here. Mass 1 is 0.44 kilograms times V1, which is 3.7 meters per second. So that gives me 1.628. M2V2 is 0 because it was not moving before the collision. Okay, and then minus 3.7 M2. 3.7 times mass 2, which is 0.22, is 0.814. And I divide that whole thing by mass 1 plus mass 2, which is 0.66 kilograms. Okay, so I have 1.628 minus 0.814 divided by 0.66. So I get V1 prime is 1.23 meters per second. Now, I have an equation up at the top that gives me V2 prime. It says V2 prime equals 3.7 plus V1 prime. That's what I found earlier. So now I just plug in the V1 prime of 1.23 and find V2 prime. So V2 prime is going to be 3.7 plus 1.23, and that's 4.93 meters per second. And those are my two answers. So I have 4.93 meters per second for V2 prime, 1.23 meters per second for V1 prime. So it's a longer process. You have to use two equations. You're going to need to do substitution. There's a couple steps of algebra involved, but it's really not all that difficult to do once you get the hang of it.